Let's do this lesson number 2, set notation. So take a second, have this in your notes before we begin, and yeah, let's do this. So from the previous lesson, recall that the roster method of writing a set encloses a list of elements of the set in braces. So if you want, take a second and look at your notes from the previous lesson just so you feel comfortable with the idea of roster method, the set, the elements, and the braces, okay? But just to do a little bit of a review, if we said, hey, let A be the set of even natural numbers less than 10, how would you write what is in this set? Take your time, right? Pause the video if you need to. What would be the set of even natural numbers less than 10? Okay, so first let's start off with an open braces, and it would go from 2, 4, 6, and 8. Oh my god, what is somebody doing? Yeah, the set of even natural numbers less than 10 would be 2, 4, 6, and 8, right? These are all natural numbers, and they're all even, and they are less than 10. If you included 0 in here, be careful. 0 is not a natural number, even though 0 is even. Okay, what about this one? Let's say if we said B is a set of even integers less than 10, but not negative. Take your time. Here it would just be 0, 2, 4, 6, and 8. So here notice that 0 is an even number, and it's also an integer, so we could put it in this set, not like this set over here. Okie dokie. So this was just a little review from the last lesson, and let's just take a look at this over here. Take a second and have this down in your notes before we actually go through it. Pause the video. Right, so let's say you have it in your notes. Here, these are the examples of finite sets. So all the elements can be listed in the set. So in here, when you take a look at examples A and B, here these sets are finite, right? Because you have a certain amount of elements within the set. Here, sometimes, or in other cases, the set of natural numbers, for example, would be an infinite set. So here we have, let's remember what these sets are, right? This is the set of natural numbers, so how does that go, right? It goes 1, 2, 3, 4, and the pattern keeps continuing, right? With that ellipsis right here, that shows that there are an infinite amount of elements within this set. Same idea with the integers, the rationals, and the real numbers, right? So all these sets are infinite sets, and you have this ellipsis to kind of show the pattern, right? Okay. Here, if the empty set or the null set is a set that contains no elements, so you could write this symbol as the null set or the empty set right here, or you could show two braces like this stating that there's nothing within this set. It's used to represent the empty set. Okay, so what would an example of an empty set look like? Let's take a look at this over here. Imagine if I said, hey, take a second and have this down, right? Let's say C represents a set of integers greater than 5 but less than 3, right? Can you think of any number within the, within the set of integers that if 5 is here and 3 is here, give me all the numbers that are greater than 5 but also less than 3. This is not possible. So we call this an empty set. Or you can say like this, right? Don't do this. This is no bueno. You don't put the null set inside a set. You just show either this or this. And that works. Okay. Another way, and what I'd like you to do is take a second and have this within your notes before we begin, right? Let's have this down. Right. Okay, so let's say you pause the video. Let's go to this part over here. Here, a second way of representing a set, right? We had one way of representing the set just like this, right? This was with the roster, this is the roster method, right? here, another way of showing a set is a set builder notation. So I'm going to show you exactly what it is right now. Here, a set builder notation can be used to describe almost any set, but it's especially useful when writing infinite sets. So let's take a look at this example over here. It says in set builder notation, what would be the set of integers greater than -3? All right, so the way you would show it is, you would show braces open, x, right? So now I want to say the set of integers greater than -3. So here, x is greater than -3, right? So notice that we're using the element of x. Here we're saying this is the set of integers greater than -3. And then we also want to say that we're using the integers, right? So then here, what we're going to do is we're going to say x is an element of the set of integers. And then voila, we're done. Okay? So then here, let's just take a look at this part really slowly. That this part here, you would say x is an element of, right? This notation over here, this little e-ish looking thing, this is the way you read this is an element of, right? Because here we're saying that the numbers are within the element of integers, right? So you can't have like this number within your set, or like what's a number greater than -3, right? A half is greater than -3, but it's not within this set. We don't have the real numbers or the rationals, we just have the integers. So then this is the way we would show the notation. You're showing first this part that you're using the variable x, this is your inequality, and this is where your set is in. So you have these three components, okay? So here what I'd like you to do is take your time and try and do these three questions on your own. Show the set builder notation, not the graph, we're gonna do that soon, but show the set builder notation of the set of real numbers less than 5, the set of real numbers greater than or equal to 3, the set of integers less than or equal to -4. Okay, take your time, pause the video, and try and show this set builder notation within these three examples. Okay. Okay, so let's say you pause the video and you want to see your solutions. Let's take a look. Here, the set of real numbers less than 5. So here we're going to show this, x, right? We're showing that variable of x. Real numbers less than 5. So x is less than 5. And then here you can say x is an element of the real number set. Okay. What about the second question? The set of real numbers greater than or equal to 3. So then here we have this. X is an element of greater than or equal to 3. So x is greater than or equal to 3. And x is an element of the real number line. Right? And let's take a look at the last one. The set of integers less than or equal to -4. Here you go. X is less than or equal to -4, and x is within my integers. Okay, not too bad, not too bad. All right, let's continue. So this part we finished with this paper. Yeah, here, graphing a set of real numbers. So here, let's say we're given two real numbers, an interval. Oh, I'm sorry. First, what you should do is, before I go with this, please take a second and copy this down, right? Let's say you copied it down, right? Given two real numbers, an interval is a set of all real numbers between the given numbers, right? So here, when we take a look at this notation, this is implying that we're within the real number set, okay? If nothing is shown. Like in this example, if the person wanted to write that you're within the integers or within natural numbers, they would have had it specifically. But here, if no such notation exists, then we're assumed that we're in a set of real numbers. And when you talk about real numbers, you have to be good with that idea, right? You're on the number line, and pause, what does it mean to be a real number, right? You're either rational or irrational, right? You're all these numbers in between, okay? So now here, this set represents all the real numbers less than or equal to 3, which is this part here, but greater than or equal, but greater than -1. So then how would you show that visually on the graph? All you would need to do is, let's take a look. If this is my -1, notice that x cannot be -1, right? You do not have -1. -1 is not included. So within the number line, what we do is we just show a parentheses like this. And then what do you think we're going to do at 3? We're going to show a bracket. So this parentheses over here and this bracket over here. And then what you could do is you can take, let's say this, and you can shade everything in between. And that this visual graph, this is the visual representation of this inequality within set builder notation. I mean, if I take a look at this graph, all it's saying, I have all the numbers between -1 and 3. I have 3, but I don't have -1. Okay? And here, if you want, you could have this in your notes that I wrote it down for you. The parentheses on the graph indicates that -1 is not part of the set. The bracket on the graph indicates that 3 is included in the set. Okay? And yeah, not too bad. Right. This is a visual representation of this. Okay, let's move on. For this part here, what I'd like you to do is, for your notes, have this down just like this, and have the orientation of your paper horizontal, right? And take a second. What we're going to do is we're going to show the graph, or what you could do is you could try and show the graph of all these set builder notations, or these inequalities. And then here I'm also going to show you interval notation, and it's really not that bad. Okay, so take a second and copy this into your notes, and then we will we'll begin. Right? Let's take a look at the first example. Okay, here, oh, it's a little weird. I can't zoom in correctly. Okay, it's not a problem. Here, okay, so how do we read this? X is less than or equal to 2, but greater than or equal to -3. So then how do you show the interval notation for this? All you need to do is show a bracket, -3, comma, 2. And that's it. What this is saying right here is that because you have -3 and you have +2, this implies that you have -3 and 2 and everything in between when I have the brackets. When you take a look at this example, for example, right? Here I have -3, but I don't have 2, because here it's saying that x is less than 2. So in here I'll show a parentheses on this side to show that I don't have 2 in this example. Okay? And if you wanted to draw both of these graphs, here, not too bad, right? This would just be like this, like this. I have a bracket -3, bracket 2, and I could just shade in between. And that shows I have everything in between -3 and 2, and I have -3 and I have 2. How would I show this graph over here? I think you probably know just by taking a look at it. It would just be like this, right? If I see this within my graph, this I know I have -3, but I don't have 2. Okay. What I'd like you to do is try and think about how you would show it for this one, right? Here, take a second. How do you read this? Here, this is x is greater than 1, right? And notice that within my interval notation, I always go from least to greatest. Okay, so notice here, it's saying x is greater than 1. So notice that if I visually wanted to see that, right, what is x is greater than 1? Let's just take a look over here. X is greater than 1. Visually, what does that mean over here? I'm at 1, right? I don't have 1, and it's everything greater, right? So it just goes kind of like this, right? And notice that it goes towards infinity. So then the way we're going to show this interval notation is we'll show that we don't have 1, and then now we're going to infinity, but the question is, should I have it as open or closed, right? Why don't you take a second and think about it. Should I have parentheses or bracket? Because parentheses includes I don't have it, brackets means you do have it, right? Infinity is always parentheses, right? Because you don't have infinity. You can't grab it, right? It's like the idea of infinity just keeps on going. Okay? With that in mind, try and do the rest on your own. Pause the video, take a second, and try and do these 3 questions, right? Here you have x is less than 1, x is greater than or equal to -1, x is less than or equal to -1. Right? Pause the video and try and draw it, right? Here, let's see, x is less than 1. So then if I'm at 1, I don't have 1, and I'm everything less than, right? So you have to be careful on how you write this, because here it's always from least to greatest. Thus, which idea should go first? It should be -infinity to 1. Because always go from least to greatest. If you wrote this like that, this is incorrect, right? Because here -infinity is smaller than 1. So here we have to have it like that. Okay. What about here? X is greater than or equal to -1. So then here, x is greater than or equal to -1, and I have everything over here like that. So then here, I'll have bracket -1 open parentheses like that. Okay, this part here, x is less than or equal to -1. So then I have this, and then I am going this way. So then I have just like that. Okay. All right. So far, so good. Let's see, how much time? 17 minutes and 50 seconds. If you feel like you need to take a little bit of a break, go ahead, pause the video. The last part of this lesson the idea is very short, but we'll push through it, right? If you want, take a second and take a little break. And if you're back, what I'd like you to do is please have this in your notes. We'll learn about the union of 2 sets, and then the other idea is the intersection of 2 sets. Okay, so pause the video, have this in your notes, right? Let's say if you have it here, the union of 2 sets, A union B, is the set of all elements that belong to either A or B. In the set builder notation, we say A union B is equal to where X is the variable we're talking about. And then how do you read this, right? Take a second and pause the video. How do you read this? X is an element of A, or X is an element of B. So what on earth does this mean? It's really not that bad. All this basically means is if I find the union of 2 sets, basically what you're doing is, what do they share? What do they share? That's the only question you should really ask yourself for now. What do they share? So let's take a look at the first example. If I say, let's take a look at A. What's within my set A? It's 2, 3, 4, 5, 6. And within B, I have 4, 5, 6, 7, 8. Oh, I am so sorry. Sorry. This is not what you want to say. My bad. This will be for an intersection. What you want to say is combine both sets. My bad. Combine both sets. Okay. This is, I'm sorry, scratch this one out. what you want to basically say is combine both sets. So here, you want to take all the elements in here plus all the elements in here. So notice that, what are the elements in here? We have 2, 3, 4, 5, and 6. And now notice that within this set B, 4, 5, and 6 are already here. So that you should remember from the previous video that never repeat elements. So then here, you don't need to write 4, 5, and 6 again over here because you already have it, but you also get 7 and 8. Notice that you are combining all the elements of set A plus all the elements of set B, and you're not repeating the elements. Okay? Let's take a look at the next one. Here, how would I combine all of the elements in C and all the elements within D? C union D would just be, pause the video and try and go through it, right? It has -3, and we could go in order, right? It also has -2, -1, 0, 1, 2, and 3. Notice we just took all the elements in here plus all the elements in here. And that's the idea of what we're doing. We're combining both sets. We're putting them putting them together, right? Let's take a look at this example. If I have 0, 2, 4, 6, 8 for set X and set Y, then this is just simply 0, 2. Notice they both share 4, so I don't need to write 4 again. They both share 6. And we also have 8. This is all the elements that are in both X and Y. Okay? If this one felt shaky because I realized I messed up a little bit over here, I'll show a better explanation in class. Okay, or we'll do a few more examples. Final part of the lesson, and then we are done. We did the union. Now let us do the intersection. Take a second, pause the video, and have this in your notes, right? This is the final page, then we're done. Here, let's say you copied it in your notes. The intersection of two sets. The intersection of two sets A intersect, that's how you read this symbol, A intersect B, is a set of elements that are common to both A and B. So then here, the way we read this is A intersect B is within the set X, with using the variable X. X is an element of A and X is an element of B. Here, we had the idea of OR. And meaning that either you have to combine both of these sets in here. The idea with an intersection is, what do they share? What do they share? Right. Here, within set A and set B, which elements are common? Which elements are common in A and B? So notice that within A and B, they share the 4, the 5, and the 6. So that's it. It would be 4, 5, 6. This is A intersect B. We're finding all the elements that are common within both. Pause the video and try and think about this one. Which elements are common in both C and D? If you pause the video when you did it, or here, there's nothing. There is no element in C that is also within, there are no elements in set C that are common in set D. So you could have showed this or this empty set, right? This is the null set, this is the empty set. Okay, so there's nothing. In this example, which elements do they both share? They both share a 4, and they both share a 6. And that is it. That is it. Okay. So what I'm going to do is I'll have your problem set ready. So it'll be a little homework assignment for you to do, for you to practice all the ideas we learned in this lesson. I hope you enjoyed the lesson, and I'll see you soon. Enjoy.